The objective for this lesson is I can decompose fractions into sums of smaller units using tape diagrams. So we're still decomposing fractions, meaning breaking them apart, but we're going to show you how using a tape diagram, you can represent the same fraction with different numbers. And here's what I mean. So here's one type of problem you're going to have. So you're going to have to look at this tape diagram in two different ways. So if you notice, the first way this tape diagram was divided was into three big boxes, and one of those boxes was shaded. Okay, so 1/3 was represented. So this first question here says, what fraction of the whole does each of those parts represent? All right. So each part represents 1/3. All right. But now, so notice you're going to look at this tape diagram in two different ways. Like I said, the big parts, and then you're going to have to look at the smaller rectangles. So the next question is, what fraction of the new parts are shaded? So here's the thing. If you're looking at the new parts, meaning the smaller pieces, you have to divide the whole tape diagram into those smaller parts too. So notice one big rectangle is divided into 4. So you would have to do that with the rest of the pieces. So now, what fraction of the new parts are shaded? So now you have to count up all the parts, which are 12. The good thing is it's going to tell you down here. And then, so what fraction of the new parts are shaded? 4. All right. So then you go down to the bottom with the equation, and you're explaining how 1/3 and 4/12 are equivalent. They're the same fraction using different numbers. So down at the bottom here it says 1/3 is equal to how many 12ths equals the total number of 12ths? Well, how many 12ths did you add that are shaded? You have 4, right? So you have 1/12, another 12th, a third, and another one. So then all you do, what does that equal? You count up, there's 4 of them. See that? 1/3 is equal to 4/12, and that's what we said right above that. And they're starting to show you, because we're going to get into equivalent fractions, and equivalent means equal. And so they're trying to show you that if I divide this into 12 parts and I shade 4, my tape diagram shaded to there. If I divide it into 3 parts and I shade 1, it goes to the same part. So 1/3 up here is the same thing as 4/12. All right. Okay, second type of problem. Right here, this says, the tape diagram below is partitioned or divided into fifths, with 2/5 being shaded. Okay, so they're telling you it's divided into 5 sections, but it may be hard to see here. So what you should do is, you have to start seeing this with your eyes. And if it was on paper, it'd be easier because you could draw over it. But you can do this on your independent practice. You can write on top of it, I think. So there's 2, there's 3, there's 4, and there's 5. You see the 5 equal parts? Don't look at the little lines in between, but see there's 5 big rectangles, and 2 of the 5 are shaded, right? The 2/5 that is shaded in was then partitioned into thirds. So they're saying they divided each of those into 3 pieces. So it says answer the questions below, then complete the number sentence. All right. So I want you to answer this first question. What fraction of the whole does each of those parts represent? And they kind of already gave you the answer up above. And when they say what parts, I'm talking about the big parts. Okay? Before they divided it smaller, what fraction was represented in the tape diagram? Right, it's 2/5, which they already gave you, although it's kind of small, writing small, but we did go over it. Right, so the original 2/5 was shaded. Now, remember what I did up here, where I had to divide the rest into smaller pieces like I did here. And they told you what to divide each of these big ones into how many pieces. So I want to see if you can figure out what fraction of the new parts will be shaded once you divide up the rest of the big rectangles into the smaller rectangles. All right, so see if you got this. The answer is 6/15. Why? Because you have to divide up the rest of the big rectangles into the same number of pieces that we did over here, 3 each. So if you count them up, 6 out of 15 now are shaded. All right. So what you do down at the bottom then is you fill in the equation. So we started with 2/5, and then we cut them all into smaller pieces. So we took 3/15 was the first large rectangle that's now divided into smaller ones. Can you tell me the 2 numbers that would go here and here to finish the equation? All right, so we had 3/15, there's 3 of them, plus another 3, so that should be a 3, and then you just have to add, right? And plus we have the answer here. 3/15 plus 3/15 is 6/15. So if you got that right, great job. And if you didn't, don't worry about it. We're going to do lots of practice with this. As always, when you're doing your independent practice, come back and watch the video if you need to. Send me a question. And if you're completely confused right now, go back before you start your independent practice and watch this video again.